Okay, assalamualaikum guys. Hopefully you guys are doing well. So today we're doing on chapter 9, centroid in composite bodies, and chapter 10, moment of inertia in composite bodies. I took this question from a past year that I've sent you guys, 2019-2020 semester 1. So this is the past year paper question. So based on figure 3, okay, it's figure 3 right here. Locate the centroid y bar of the cross section and determine the moment of inertia in the section about the x prime axis. Draw your reference diagram and clearly indicate any equation that's used for calculation. The geometric properties are given in the appendix. So in order to find y bar for a composite body, it's summation of y tilde, okay, area over the summation of area. Okay, what is y tilde? Y tilde is basically the distance, okay, the vertical distance of a shape's centroid to the reference axis itself. Okay, so that is what we call as y tilde. Okay, and a is the area, which is the area of the shape itself. Then later when we need to find the moment of inertia, we have to use the parallaxes theorem formula right here, which is basically the moment of inertia times the area of the shape and the distance of the centroid from the reference axis itself. Okay, this is what we call as dy. Okay, so they mention about the appendix, right? The geometric properties are given in the appendix. So this is the appendix they'll tend to give you in the final exam. Like I mentioned, it's just only semicircle, circle, rectangle, and triangle. They won't give you anything more complicated than that. Okay, and all right, let's proceed with finding the centroid. So before we do that, we have to draw a reference diagram. So I'm going to draw a simple reference diagram right here. So it's x, okay, and y. Alright, and okay, so this is a reference diagram which looks something like this. I know it's not very accurate, but you don't have to worry about the accuracy about it in your exams. So I split it into a rectangle right here, which we call as section 1, another rectangle section 2, a triangle we call as section 3, and another triangle we call as section 4. Okay, so this is a reference diagram. Okay, and I'm gonna make a table actually, because it's best to make a table when you're trying to find the centroid across the y-axis. So section area, okay, y tilde, and let's see, y tilde area. Okay, so with that being said, let's try to solve the problem. 1, okay, 2, 3, and 4. Okay, summation of area and summation of y tilde area. Okay, so with that being said, so section 1, what is the area? So it's a simple rectangle. I think this is 0.05, right? 0.05 meters, right? And this whole thing is, you have to add up all these values, by the way, yeah? Okay, which I think I got was 1.1. Okay, so this is 1.1 meters. Okay, so the area is just 1.1 times 0.05. This simple rectangle, 0.055. Okay, remember it's meter square, so don't forget to label your units like I'm doing right now. So therefore your lectures will give you full marks for that. Now for section 2, we know that this part is this part is 0.3 meters, and this whole thing is 0.4 meters. Okay, 0.3 and 0.4 meters. So it becomes 0.12 meters squared, right? 0.12 meters squared. Okay. How about for section 3 and 4? Okay, so section 3, I think this is 0.2 meters, right? This is 0.2 meters is a right angle triangle. The same also for section 4, so they're both the same shape. So therefore the area should be pretty straightforward. It's just half times 0.3 times 0.2 times 0.4. Okay. Let me just make sure, right? So it's 0.04. Okay. So you add up all together, you should get 0.055 plus 0.12 plus 0.04 plus 0.04, 0.255. Okay. That should be clear, right? On how we determine the area. Because for section 3 and 4, they're just triangles. It's very easy. It's just half times base times height. And for section 1 and 2, rectangle, it's just base times height. Okay. Now, how about y tilde? How are you going to find y tilde? So y tilde, like I mentioned to you earlier, is the distance from the centroid of each shape, right, relative to the reference axis, which is the x-axis in this case. Okay. So basically, x prime axis of the shape to x. So for the case of the first one, since the centroid is located right in the middle of the shape, and therefore the distance of it from the x-axis will be 0.05 divided by 2. So if we do this for section 1, the y tilde is just simply 0.05 divided by 2. There's no y bar, yeah, y tilde. Okay. Should be 0.05 divided by 2. 0.025. 0.025. Okay. Clear? Now for section 2, how do you find the y tilde? So to find the y tilde, it's basically, it's here, right? So you need to consider the distance of 0.05 and half of this one, okay? Then you can actually get your y tilde. So in this case, it will become 0.05 plus 0.4 divided by 2. So it'll be 0.05 plus 0.4 divided by 2 becomes 0.25 meters. Okay, so that's your y tilde, 0.25. How about the triangles? Now the triangles, like, what's interesting is that the centroid here actually is just 1/3 the height. So it's 1/3 the height from this area of the triangle. Okay, so that is for the case of triangle, and you have to add it with the 0.05. Then you can only find the y tilde. So in this case, the y tilde is y tilde 0.05 plus 0.4 divided by 3. Okay, so I just changed it. 0.4 divided by 3 is just 0.0674 meters. 0.0674. Okay, and the same also applies for 4 because they're both the same exact triangle. So therefore the distance also from here to here, the reference axis is the same. Okay, now how to find this y tilde a is very simple. You just multiply these two only. That's it. You have to just multiply and then you can get the answer pretty easily. So 0.055 times 0.025, 1.375 10 to the power of -3. 0.12 times 0.25, 0.03. 0.04 times 0.0674, 2.696 times 10 to the power -3, 2.696 times 10 to the power -3, 0.04 was 0.0674, 2.696 times 10 to the power -3, again because they're the same triangle. Okay, add up everything to get the y tilde a summation. Oops. 0.03 plus 2.696 times 10 to the power -3 plus 2.696 times 10 to the power -3. 0.0367 0.067. Okay. So with that being said, we can easily find the y bar, which is rotate page. So y bar is equivalent to summation of y tilde a over summation of a, which is 0.0367 over 0.255 meters squared. Zero point 1441. So yeah, this is your y bar actually from the axis. So this is your first answer. Now we're not done yet because we need to figure out the moment of inertia of the section about the x prime axis. So we need to figure out the moment of inertia along this axis. Okay, so I'm gonna draw another diagram again, a similar diagram in the next page to make it more clear. Okay, so we have this diagram. Okay, right, and we have the x prime axis. Okay, right, and we already know the y bar, which we're already given to be if I'm not mistaken 0.1441 meters. Now to find the moment of inertia for all the sections, section 1, section 2, section 3 and section 4, right, we have to use this parallel axis theorem, which Ix prime is equivalent to Ix bar plus a dy squared. Okay, so Ix is the moment of inertia with respect to the x-axis for each of these shapes. A is the area of the shape itself, each of the shapes, and dy is the distance between each shape's centroid with respect to the axis itself. Dy can be positive or negative, by the way, right? But at the end of the day, when you square it, then it's gonna be a positive number, so it doesn't really matter. Okay, so let's try for each section right now. So for section 1, so the Ix prime for section 1 is equivalent to Ix bar. So Ix bar in this case, if you refer to the appendix actually earlier, it's 1 over 12 BH cube. So it'll be 1 over 12 BH cube plus the area, in this case is BH, and dy is the distance. So our distance actually, since if this is 0.05, the whole thing is 0.05 meters, and we're looking at the centroid right here, which is obviously half of that, so this would be your dy. Okay, so your dy would become 0.1441 minus 0.05 over 2 squared. One thing to note that this will be negative because it's going in this direction, but like I said, once it's squared, it'll become a positive number at the end of the day. This term will become positive, so this should not be a problem at all. So you plug in the values, 1 over 12. Your base is 1.1 meters, if I'm not mistaken. Right? So 1.1 meters. Your height is 0.05, so 0.05 cube plus BH is 1.1 times 0.05, and this one is you can calculate 0.1441 over 0.05 times 3 by 2, 0.1191 1 squared. Okay, or 12, 1.1 times 0.05 cube plus 1.1 times 0.05 0.1191 squared. So your moment of inertia for section 1 is 7.916 times 10 to the power of negative 4 meters to the power of 4. Okay, this is for section 1. How about section 2? I think we can do the next page also. It'll be much more clearer. Rotate. So section 2. So Ix prime is equal to Ix bar plus A dy squared. So same rule also applies, is again 1 over 12 bh cubed because it's a rectangle. 1 over 12 bh cubed plus bh. Then your dy in this case, because your centroid for section your centroid for section 2, right, for this section, it's somewhere along here, so you need to find the distance of this centroid towards the x prime axis itself actually. So we know that this height, if I'm not mistaken, is 0.4 meters. Let me just double check before I say anything extra. 0.4 meters. Okay, 0.4 meters. So it must be 0.2 meters. So half of 0.4 must be 0.2 meters, maybe somewhere lying along this line. So we need to know the difference between that 0.2 meters and this one. We need to know that difference. That would be your dy. Okay, so how do we tackle this problem? So 0.05 plus half of this one, how much will that be? Okay, so it will be 0.05, okay, meters plus half of 0.4. How much is that? 0.05 plus 0.4 divided by 2. 0.4 divided by 2. 0.25 meters. Okay, so this from this centroid, okay, this whole thing, okay, is 0.25 meters. But the distance of the x prime axis to the ground is 0.1441 meters. So this is obviously bigger than this one, right? So by finding that difference, we can easily find the dy in this case. So it is just 0.25 meters subtract 0.1441 squared. Okay, so 1 over 12. Our base in this case would be 0.3, if I believe, if I'm not mistaken. 0.3 meters. Let me just double check in the diagram. Yeah, 0.3 meters. Okay, so becomes 0.3, 0.4 cube plus 0.3 times 0.4, and this is 0.25 minus 0.1441, 0.1059, so 0.1059 squared. Okay, then if you plug in everything, so it's 1 over 12 times 0.3 times 0.4 cube plus 0.3 times 0.4 times 0.1059 squared. So it becomes 2.946 times 10 to the power of negative 3 meter to the power of 4. So that is for section 2. Okay, now we proceed for section 3. Okay, so section 3, right, the formula is Ix prime equals to Ix bar plus A dy squared. So in this case, section 3 right here. Okay, we have section 3 right here. Okay, so how do we find the Ix bar? The formula is also given in the appendix as well. It is just, if you can't see it clearly, it's supposedly 1 over 36 bh cubed, okay, for Ix. So I'll write it right here to make it more clear. It's just going to be 1 over 36 BH cubed. Plus area we know is half times BH for any right angle triangle. How about the dy? Okay, so you see, this is where the centroid is for the triangle, right? It is just 1/3 of the height, okay, of the triangle. And we have to consider this centroid to the ground, how much is the distance, and we have to subtract this distance with this distance. Then you can only get how far is the centroid from the axis, which is our dy in this case. Okay, so remember, it is this distance subtract this plus 0.05, you'll get your dy. Okay, so 0.05 plus 0.4 over 3, how much is it? 0.05 plus 0.4 over 3, you get 0.183. So it is just 0.183. Oh, okay, so it's actually a little bit more, to be honest. It's a little bit more than here. It's supposed to be somewhere along here, a little bit more than the distance actually. Okay, so that difference will get you the answer. So 0.183 minus 0.1441 squared. Okay, so it's 1 over 36. Our base in this case is, I believe, 0.2 actually. Meters, let me just double check again. Yeah, 0.2, and this is also 0.2. So because it's the same triangle, right, like I mentioned earlier, so it's also 0.2 meters as well. Okay, so base is 0.2, height is 0.4 cube plus half times 0.2 times 0.4, and this one was 0.183, 0.0389. When you compute it, what should the answer be? So 1 over 36, 0.2 times 0.4 cube plus 1 over 2 times 0.2 times 0.4 times 0.0389 squared, 4.161, okay, times 10 to the power of negative 4 meters to the power of 4. Okay, this is for section 3. Now we are doing for the last section, section number 4. Okay, so section number 4. So therefore it is just Ix prime equals to Ix bar plus a dy squared. Again, since it's also a triangle as well, just like section 3, the triangle as well. So therefore the moment of inertia for this part is 1 over 36 BH cubed plus half times B times H and dy squared. Okay, now dy squared, again, like I said, is the distance from the centroid, obviously, to the axis, right? Okay, the procedure is the same as 0.05, and this is 0.4 time plus 1 over 3, which I think we got last time already. This value right here, the same value we're going to plug in as well. Okay, so essentially it's the same actually as your section 3. I'm just going to plug in this one. 0.183 minus 0.183 minus 0.1441 squared. Okay, so it's the same equation. I just plug it in only. Times 0.2, 0.4 cube plus half times 0.2 times 0.4, and this one is 0.0389 squared. 0.0389 squared. So you compute everything, you should also get the same answer. 4.161 times 10 to the power of negative 4 meters to the power of 4. Okay. So after you've found all the moment of inertia along that x prime axis for each shape, you just have to add them up actually and you'll get the final answer. So therefore the resulting moment inertia, okay, would be from section 1, from section 2, from section 3, and from section 4. Okay, so if you add them up, I believe you should get about, so 7.916 times 10 to the power negative 4 plus 2.946 times 10 to the power negative 3 plus 4.161 times 10 to the power negative 4 plus 4.161 times 10 to the power negative 4. Okay, so if we add them up all together, we should get 4.5698 times 10 to the power of negative 3 meter to the power of 4, or becomes 4.57 times 10 to the power of negative 3 meters to the power of 4. So this is your moment of inertia along x prime axis. Okay, so moment of inertia along x prime axis. So I hope that this tutorial actually has helped you guys to understand the underlying concepts of centroid in composite bodies and moment of inertia in composite bodies. And usually in the exam they tend to combine these two chapters in one question actually, and they give you like about 13 marks. So I think the mark distribution maybe here could be about 6 or 7 marks here, and maybe to calculate the moment of inertia is also about 6 to 7 marks as well. So yeah, that's about it guys, and I hope this tutorial will be beneficial, and I'll see you in the next one. Assalamualaikum warahmatullahi wabarakatuh.